Today's video will be solving some questions from Work and Energy. Starting with the first one, which reads, a pump is needed to lift water from a well through a height of 3 meters at a rate of 0.6 kg per minute. What must be the minimum power of the pump in watts and in horsepower? Well, this is our solution. So they want us to find the minimum power of the pump. Okay? So we are finding the power of the pump given the height to be 3 meters. Okay, the height of the well to be 3 meters. What else? Okay, we've been given those. All right, so how do we find power? Well, power is given by work or energy over time. This is simply the rate of doing work, right? Yeah, but you just choose one, whether you use this one or this one. It's just one and the same thing. Okay, then we've been given the rate to say the pump is pumping this water at this rate, right? Meaning that so we have height as 3 meters. What about the mass? The mass, we have it here, which is 0.6 kg. What about the time? So from this we are able to get the mass and the time. So 0.6 kg of water is being pumped per minute. Okay, but time is supposed to be in seconds, so per minute, right? So 1 minute is equal to how many seconds? 60 seconds. All right, amazing. So now how do we find? So yeah, we can start. We can start. What is the time? The time is 60, right? Yes. But what about for the work? So the work is the same as energy. In this case, what type of energy is this? This is the potential energy, gravitational potential energy, which is given by mgh. Okay, what is the mass? So this is our dot, right? What is the mass? 0.6. Gravity 9.8. What is our height? Our height is 3. Therefore, punching gives 17.64. Energy is in joules. So this is the same energy we put here, 17.64. Yeah, 64 joules. So 17.64 divided by 60 gives 0.294 watts. So this is the minimum power of the pump in watts. Okay, what about in horsepower? Well, we just have to convert from watts to horsepower. Okay, or from horsepower to watts. Watts to horsepower, right? So 1 horsepower is equivalent to 745.7 watts. Okay, some, instead of using 745.7, they just use 746. They round it off. Right, so how many horsepower? We don't know. Watts we know, 0.294 watts. So when we cross multiply, we'll have something like 745.7 x is equal to 0.294 over 745.7 over 745.7. So this will give us 745.7, give us something like 0.0003946, yeah, which can be written as horsepower. Okay, but this can be converted to scientific notation, right? Okay, so 1 2 3 4, so you can just say 3.94 by 10 to the power 234 negative 4 horsepower. Okay, then we can say therefore, okay, therefore power is equal to 0.294 watts, and we can use this one if we want 3.94 by 10 power negative 4 horsepower. So this is our solution for the first part, for question 1. Yeah, for question 1. So we now move to the second question. So just learn. Okay. The second question reads, a bead of mass. Okay. All right. So here there is a bead of mass somewhere. This is just showing the height, right? Yes, but there is a bead of mass. Yeah, there's something here. Okay. Amazing. So the same bead of mass, 15 kg, is sliding. So this thing is sliding on a wire. This is a wire. It has a speed of 2 meters per second at A, right? And it stops as it reaches the point C. The length of the wire from A to C is 250 centimeters. So the length of the wire from A to C is 250 centimeters. How large an average friction force opposed the motion of the bead? How large an average friction force opposed? So yeah, just like I was saying, there are different ways of doing it, right? But one of the ways you can do it here is simply relating the energy changes. Okay, the work energy theorem, right? Yes. Yeah, and to simplify it further, I will just say the energy at point A, okay, minus the energy at point C is equal to the friction force energy. If you didn't get that right, let me put it in terms of work, right? Because we know work and energy is just one and the same thing. So the work here at A minus the work at C is equal to the work done by friction force. The difference in energy at point A and point C is equal to the what? To the energy of the friction force, the work done by friction force. In other words, we are going to say, so this is solution. So we're going to say friction force energy, or the work done by friction. So we can just say work done by friction force is equal to the work done at point A minus the work done at point C. Work is the same as energy. Amazing. Now, at point A, this thing has got, we've got a height. Okay, we've got this height. So this thing at point A has got potential energy. Yes, it has potential energy. What else does it have? Since it also has the velocity of 2 meters per second squared, this simply means that it has got, at point A, it has got both the kinetic and potential energy. So we are going to say the work done by friction force is equal to, so at point A I've got the potential energy, this is the potential energy, plus we also have the kinetic energy, minus at point C, this thing has stopped moving, it's no longer moving. When something is not moving, it does not have kinetic energy. Therefore, at point C, since we have got a height, we only have potential energy. Amazing. But now, what is the mass of this same system? Well, the mass of this is 15 grams, but we need to convert it to kilograms. How do we convert? 1 kilogram is equal to 1000 grams, right? So we have got 15 grams. We don't know. When you cross multiply, you find that you will be dividing 15 over 1000, which will give you 0.015. So the mass is 0.015. What is the gravity? Gravity will use 9.8. What is the height at A? The height at A is 80 centimeters. How do you convert from centimeters to meters? Well, you say 1 meter is equal to 100 centimeters, right? Therefore, 80 centimeter is equal to 0.8 meter. Plus, we have kinetic energy. Kinetic energy is 1 over 2 mv squared, right? Yes, 1 over 2. What is the mass? The mass is 0.015. The velocity is 2 meters squared, right? So, yeah, squared multiplied by that. Okay. Yeah, multiplied by that over that. Therefore, the kinetic energy is 0.03. So, since I found the kinetic energy at point A, I'll just replace plus the kinetic energy, which I've just found to be 0.03. Okay, so this entire thing minus this. Okay, so the mass remains the same, 0.015. Gravity remains the same. Height changes. Here, the height is 50, right? So, we'll say 50 over 100, which will give us 0.5 meter. So, From there, we can actually punch. Let's start with punching. This part, so it will be 0.015 by 9.8 by 0.8. Then the answer plus 0.03. I'm getting 0.1476 minus 0.015 multiplied by 9.8 multiplied by 0.5 gives 0.0735. So 0.1476 over minus the answer, yeah, which is 0.0. So this minus this, right, gives 0.0741. We're dealing with weight, right, which is joule. Amazing. But even if we are saying amazing, the question requires us to find the what? To find the friction force. This is the work done by the friction force, but they want us to find the friction force. We found the work done by friction. Well, how do we find the work done by friction or the work done? What is the formula for work done? Well, work done is equal to force times distance. From this formula, we can make force the subject of the formula. Okay. In this case, since we are dealing with friction, so this will be the work done by friction being equal to the friction force, right? Multiplied by distance. Making F the subject of the formula gives this. So it will be something like this. Then F, which is friction, is equal to work done by the friction force over the distance moved. Okay. Therefore, the average friction force is equal to the work done by friction, which is this one, 0.0741, over the distance moved. This thing moved a distance of this, okay? Because they are saying that the length of the wire from A to C is 250 centimeters. So what is 250 centimeters in meters? So just divide by 100, which gives 2.5 meters, so 2.5 meters. Therefore 0.0741 over 2.5 gives 0.02964. 0.0296 Newton. So this is our final answer. Okay, this is our final answer. Thank you so much for watching. Really appreciate.